Okay, this video is going to be talking about rational exponents, and that's what this section is. This is 6.4, so rational exponents. When we get to exponents, we're going to be talking about some roots and exponents and kind of how they are similar, how we can rewrite roots as exponents and exponents as roots. So we see the first problem here, but before we do that, we need to look at some different things. So roots, doesn't matter if they're square roots, cubed roots, fifth roots, whatever it is, roots can always be expressed as exponents. Okay, roots can always be expressed as exponents. Exponents can always be expressed as roots as well. It might change a little bit, but it can go vice versa. And when I mean by expressed, I mean they can be written that way. Okay, they don't necessarily have to be written as a root. It can be written as some number to some power up here. And that's what we're going to learn first. So we need to know a couple things. One is that if I have a root at the nth root, so this means any number. This could be 2, 3, 4, 1,000. This n doesn't matter. I have some number on the inside raised to a power. This power could be 1. It could be, again, 6 million. It doesn't matter, but it's raised to a power. Because I said that roots can be expressed as exponents, this is actually the base, a, and then now your exponent is going to be the variable, the exponent that was currently on the a, divided by the root, okay, divided by the index. Remember, this is what we call index, okay? So this is a to the m over n now. Now it looks like a fraction, and some of them will be fractions. If I see up here, they are. And then the fractions ones are going to be easier. So now we can go backwards as well, and I could say a to the m over n is equal to the nth root, because the denominator goes outside, because it's the root. The denominator is the root, and then the base to the power, or I could also write it this way, the nth root of a and all of this raised to the power of m. So raised to the power of m. That would be the same thing. They're both the same. Okay, so now what we're going to do is use this information to talk about these first couple problems here. We'll do a couple here, we'll do a couple in the next section, and then the third section here will get to some other rules that we need to talk about for that section as well. So let's kind of get started here. Let me erase all of this, because you should have that in your notes, right? Write it in your notes. What I want to do is write this in radical form. Radical form is I need some sort of root. My denominator is the index. My base here, which is actually 7n, all of that is going to be raised to the 2 power. This is your answer. Okay? Now, what if I wrote it this way? The third root of 7n squared. This one would be wrong because it looks as the n is the only thing squared. In this part, 7 and n are squared, so this would have to be the parentheses there. Or you could write it as 7n with parentheses around the whole thing squared. So this is an answer, this is an answer. Now this is the corrected answer, right? We corrected that. So that's how we do it. The denominator is the index. The numerator is the exponent on what the stuff is in parentheses. Okay, let's go to the next problem. Alright, so again, I want to write this in radical form. This is not in radical form. When I want to express something in radical form, that means my answer is going to contain radicals, or roots. Now, denominator is index, 4. 2x, all of it raised to the 5th power, okay, or the 4th root of 2x and all of that raised to the 5th power. They're both sufficient. Okay, you cannot have no parentheses. You have to have them somewhere. So if you have them here, then there you go, or you can have them all around it and put that up there as well. Either or is fine. I'm going to put 2 more examples on the board. I want you guys to work on them and then hit play when you guys get done. So go ahead and do these 2 problems, number 3 and 4, the same way. Write each expression in radical form. Hit pause and then hit play. So this one here is going to be the third root of 6m. Why did I not put parentheses in an exponent of 1? Well, isn't an exponent of 1 just keep everything the same? So this has 3 ways to write it. This is one way. I can write it as the third root of 6m to the 1, or I can write it as the third root of 6m. those are all okay because of the exponent is a 1. If it wasn't a 1, then there's only going to be 2 ways to do it. Number 4, this is now a square root of 3x, all of it raised to the 5th, or the square root of 3x and all of that raised to the 5th. Do I need the square? I don't think so. You don't need to write it if you don't want to, but you can if you want to, just to make sure you understand what's going on. So that doesn't need to be there if you don't want to write it. I'm lazy. I wouldn't write it. All right, you got a couple more examples to work on yourself, and I'll move on to the next section here. Okay, this is the next section. So what I want to do now is I want to write this in exponential form. That means I want to have some number to some other power, so maybe a or b or c, whatever the number is up here. There's no roots. I want no roots. I want to get rid of them. They're here. I want no roots in my answer. Okay? 0, zip, nada, zilch. Those are all words for 0, by the way. So what I want to do is I want to take the number that is inside, the 6a, and I want to raise it to a power over 3. Where did I get that 3 from? This is my denominator when I write it into a fraction. That's your denominator. Just like it was your denominator here, and then I put it as my index, it's vice versa, both ways. What's my denominator? Well, what's my numerator? What is the exponent on, if I put parentheses around the 6 and a, what is the exponent that's technically up here? Well, that's a 1, so that's a 1. Okay? Now, if I look at this, this looks like just the a is to the 1/3. What do I need around this that I needed around everything else? I need parentheses. This is your answer, and that is the only way to write it. Well, there is another way, but we'll get to that later. This is the only way to write it as of right now. Okay? Parentheses around what's inside. So 6a, parentheses around it. The exponent that you had divided by the root. Okay? Or the index right there. 6a to the 1/3. Next one's up. Okay, this one here. There is no number here that's written, but we should hopefully know that that's a 2 because it's a square root. So I'm going to take the thing that's inside. I am going to put parentheses around it like I talked about in the last section, or the last question, sorry. I'm going to put it to the power that it was already raised to, which is the 5. And I'm going to divide it by that root, the 2. So 6n, all of that raised to the 5 halves. And there you go. That is your only answer. All right, I'll put 2 more problems up on the board, and I want you guys to work on them and then hit play. This one here looks pretty similar to what we did on the last question. This is technically a 2 there, right? You need to remember. So the 7b in parentheses raised to the 5 halves, because your denominator is the 2. This one here, I'm going to take the x, put it in parentheses. I don't care if it's one term or multiple terms like over here. Better off putting them in parentheses just to make sure you're good. What is the exponent on the x? It's a 1. What is the root over here that's invisible? That is a 2. So x to the 1/2 power. That is how you do that. Let's go on to the last section in this paper. Alrighty then. It now says simplify. Okay, simplify. Well, first, before we do this, we need to know something. This is what we call a power rule, or power to a power. You'll often refer to it as that as well. But I refer to it as a power rule. That's pretty much what it is. What it says is that if I have a base to a power, a base to a power, another base to another power, all of this being raised to another power, meaning if I'm taking a to a number and raising it again, what this means is I'm going to take a to the bg. You notice I multiply them. So what I'm doing is this is actually like the distribution property of exponents. So this is like the distribution property of exponents. So this g gets multiplied by the exponent, this exponent, and this exponent. So b times g, d times g, f times g. So what happens here is I am going to take x to the 3 times 4 over 3. If you use a calculator for this, which is what I suggest, if you can't do it in your head, then you should get x to the 4. And that is your answer. That was pretty simple. Multiply powers. Multiply powers. Use a calculator if you can't do it in your head. That is okay. Next example here. Okay, I'm going to take this power, I'm going to multiply by that power. So it's v to the 3 times 2 over 3, which is equal to v to the 2. Boom, you're done. Again, use a calculator. Let's get to some harder ones here. Now we have numbers and we're like, what? A number to a half power? That's not going to make any sense. So let's start it out. What is the stuff inside? It's 36 m to the 4. I have a power on the m, but I don't have a power on the 36. It's invisible, but I do have technically a 1, right? So I'm going to now raise it to the 1/2. We said this was the distribution property of exponents. So I multiply, I get 36 to the 1/2, and m, 4 times a half, you can do that on your calculator, and that is 2. But I don't like 36 to the 1/2. So what you're going to do is you're going to get your calculator out, 36. You're going to raise it. Remember, your caret button is your raising of your exponents. Open parentheses, 1 divide by 2, close parentheses, and your calculator will spit out a number of saying that's 6, which it is, because technically this is the square root of 36. That's what that 1/2 power means. So the square root of 36 is 6. That's where I get that 6 from. So this we know is 6. The m squared is right there. So this answer is 6m squared. Okay? Hopefully that wasn't too confusing. We'll do a couple more, but basically that's pretty much it for this video. We'll do a couple more, though, just as practice. Let's do this one here. So again, I want to take my numbers. I want to write them with exponents. And I want to raise it to the 3/2. Distribution property, distribution property. So it's 81 to the 3/2. N, if I do this on a calculator, 6 3/2, I actually get 9. Okay? Then I'm going to take the 81 to the 3/2, and I'm going to take 81, your caret, open parentheses, 3, divide by 2, close, enter, and you should get 729. And the reason why you get a bigger number is this, because this is actually the square root of 81 to the 3rd power. Okay? 81 to the 3rd power is some large number, and then if I square root that large number, I get 729. Because your numerator is bigger, here, you're going to end up with a larger number when you actually put it in the calculator. If the numerator was smaller, like in the last video, it was 36 to the 1/2. This was smaller. That's why I ended up with a smaller number. Numerator bigger, bigger number. Numerator smaller, smaller number. Okay? So this is your answer as 729 n to the 9th power. Let's do one more example, and then you'll have a couple to do yourself. So let's look at 18 here. It's 343. We talked about to the 1st power. I don't have a power there. P to the 6 and all of that to the 4/3. So distribution property says I do that. So it's 343 to the 4/3. And then P, again, calculator, that's 8. So what we talked about in the last video was because my numerator is bigger, I'm going to get a bigger number than 343. If you do your calculation and you get a smaller number, that means you did it wrong. So let's plug it in. 343 caret, parentheses, 4 divided by 3, enter, you should get some value. And that value is 2,401. You'll notice it's significantly bigger because the higher the numbers are, the bigger the numbers over here are going to be. So, what do I got to add? P to the 8. So that is your answer for that one. I'll put 2 more answers up on the board, and then you should be good to go. Okay, go ahead and work on these 2 examples yourself. Hit pause and then hit play. Okay, those are your 2 answers for 21 and 22 here. I'm taking 625 to the 5/4. When I do that on a calculator, remember hit the caret and then parentheses around 5/4. You should get 3125, and then P to the 5th. Once I multiplied those 2, I got the 5 there. This one here, this is technically saying I'm going to take the square root of 16x squared. What's the square root of 16? 4. What's the square root of x squared? Remember, I can divide. 2 goes into 2 one time. That's how I get that left over. Boom goes the dynamite. There you go. All right. This concludes your first video. If you need additional help on subsequent videos, please check them out.